Hi, I am Anjana Sharma from TELCOMA Technologies. So let's understand LTE optimization. Now LTE optimization, that means my user equipment is in contact to e-NodeB, and e-NodeB is for the contact with the core network. That means the interface between the user equipment and e-NodeB is radio interface. Now this radio interface, or I can say that this is air interface, which is highly lossy medium. So that means radio interface or air interface has many parameters which are known as radio parameters. Radio parameters or radio link quality, which results in network performance. Network performance. Now, we require that my network performance should be good. I require that if I am an optimizer, I require that my network performance should good. That means my radio parameters should be good, and in return UE should get good services. That means which is directly related to the quality of service. That means these all are interrelated. Good radio network conditions, good radio parameters, good network performance. So optimization basically deals with when we have network performance issues. Whenever we have network performance issues, that means we want to remove the issues. So for removal of that issues, we have optimizers. That means those who will optimize the network, remove all the issues that we are facing in my network. So optimization. Now radio parameters. We have various radio parameters, like one is RSRP, reference signal received power. So this is a parameter which is there in order to get power from the network. So we are getting power from the network. So network is e-NodeB and B user equipment. So that means RSRP value is there that we are getting from the network. So that will, if RSRP value is good, so I will have good coverage. So if RSRP value is not good, so that means I have a poor network performance. So poor network performance, that means I am facing some issue related to performance. Now I want to remove that issue. So that issue is basically, removal of that issues is basically with optimizer. That means to optimize the network, to find out the particular values, to check out the solutions, that how to remove particular issues in the network. So that is the work of optimization. That means you are going to remove all issues which we are facing in the network. Optimization, to optimize the network, to find out the problems and to find out their solutions. As I have deployed the network, so it is not 100% accurate always that it will run accurately 100%. It will have some issues, so there should be regular optimization so that you can remove the particular issues which we are facing. To find out issues, to find out solution is basically the working of optimizer, or the process is optimization process. So as we have number of parameters in our network, like one I have told you, RSRQ. So each and every radio parameter has KPI defined. Now KPI are key performance indicators. Now key performance indicators like of each and every parameter, like one is RSRP and another one is RSRQ. These are the two parameters in our radio interface. RSRP is reference signal received power and RSRQ as reference signal received quality. Like this we have SINR also, signal to interference, noise ratio. Now I can compare that RSRP and RSRQ with RX level and RX quality which we have used in our GSM system. That means reception level and reception quality. In this LTE we have RSRP and RSRQ because we have reference signals to send the power in LTE. Now for KPI we have defined the minimum values and the maximum values. Minimum and the maximum value, and my RSRP value should range in between these values, minimum and the maximum values. So minimum and the maximum values, these are my key performance indicators that will judge my radio network performance. If RSRP value is minimum, then I require a handover to another cell because my home cell is not able to provide me a good power, so I require a handover to another network. So these are, that means whatever we have the minimum and the maximum value of each and every radio network parameter, these will be my key performance indicators. Now optimization basically a process, that means it is divided into number of parts. We have deployed the network, that means planning. After that, we are using the network. Now we require continuously optimization of that network. So that means optimization is, we have site level, we have cluster level optimization, and the market level optimization. So that means for optimization process and to find out the value, key performance indicator of each and everything, we have divided the optimization process into 3 levels. Site level, cluster level and market level. And this, you know that the size of the cell will go on increasing. So let's start with very first, that means site level optimization. Site level optimization basically deals with the single cell, because it is a site level optimization. So we require to focus on a single cell. On this is, if this is my LTE cell, so single cell. And this test, whenever we are testing only a single cell, the testing of only single cell is known as SCFT, which is single cell function test. Okay, I have planned a site over here. We have given a frequency, bandwidth, and users are using this cell. Now I require that there should be single cell function test of each and every site, so that I can find out the various parameters from this cell. So basically optimization is related to drive test also. So we have to drive the cell. We have to drive the whole cell and record the various parameters. Because an optimizer cannot record the various parameters which is there in air interface. So we require a software for that, and that software is drive test software. Now you can use either a clockwise direction or you can use either an anti-clockwise direction, both directions. That means whenever we are performing a single cell function test, we have to find out all parameters of a single cell only. Now this test, that means whenever we are using or performing single cell function test or a single site level optimization, so we have to find out maximum throughput or maximum data rate. So that means where is the location? The location is close to the site. You require to close to the site if you are using a single level optimization, because you have to find out the maximum throughput. Next parameters, we have to find out the handover, which is intra-cell, not inter-cell. We have to find out intra-cell handovers. That means you require to move in a cell and you have to find out that is the handover procedure is okay whenever user is moving from one cell to another cell to another. That means 2 seconds the user is moving. So first is required to find out maximum throughput. We require to find out intra-cell handover, and also we require to find out handover latency. Latency is the minimum time for handover decision. And after that, the parameters which we require in single function test is RSRP values, RSRQ values, signal interference noise ratios. That means in single cell function test, we mainly focus on a single site and we revolve on it and we record and calculate each and every parameters. Now what happens if there is some problem in the single cell function test? That means we are not getting maximum as expected one throughput. We have used here a bandwidth of 20 megahertz, but in results we are not getting a maximum throughput. That means you are having some issues. So that we require to find out in single cell function test. In single cell function test, the optimizer has to find out all hardware related issues. Hardware related issues, or if there are any issues related to configuration. That means on the whole, what are the problems if you have accurate values in KPI ranges of these, this is okay. But if the values are not that much, that means we require to optimize this site. We require to optimize the intercell. Why handover is not between different sectors? What are the hardware related? If there is a hardware related issue, why you are not getting maximum throughput? What are the reasons? That means we are testing only a single cell. My focus is on a single cell itself. That means I want to remove all the issues, all the radio link parameters of this site, because here is the user and here is the radio. But so we require to find out all radio link parameters of a single site. That means on a whole we are testing a single site. Is there any problem in a site? Now moving toward, after testing all the sites in the network, we require single cell function test of each and every site in the whole network. After single cell function test, we have cluster level optimization. So cluster level, we have cluster defined in our planning part. So after defining the cluster, now comes the work of optimizer. That means the optimizer has performed the single cell function test of each and every site. Each and every site, the single cell function test is okay. Now we have to find out the cluster level optimization. We have to find out the route between different cells. And route should be defined like this, that it should cover each and every area, even minor roads also. That means we require to cover highways as well as it is required to cover all throughways. That means the major road connecting and the smaller one roads. Because now in this cluster level optimization, we require to find out parameters which are majorly related to our handovers. Now, drive tester will drive from following the one route and record each and every parameter. So, if in between this there is a handover failure, so I will mark here like okay, I have a handover failure between two cells. That means there should be intercell handover, because you are moving from one cell to another cell, and in result there is some handover failure. So what is the reason why there is handover failure in two cells? So this is the area which we require to optimize. Here, what are the parameters? Because currently the drive tester has recorded each and every entity. Now it is the work of the optimizer that now optimizer has to find out all the parameters that why there is a handover failure in this. Like in highways you are traveling, is there any handover between from one cell to another cell? What are the values? At what area we are getting handover? Because we are recording. And the next is we have to find out average throughput. Now, why average throughput is calculated? Because now we are moving. Now case of high mobility. We are moving. What are the data I am receiving? Because if a person is close to the site and sitting idle and it is accessing internet, then obviously all the data will be transferred. But whenever we are having some mobility, that means we are having a handover, so it is required that your data session should be maintained. So where you have a data drop, what is the average throughput data rate we are receiving? So these are the values which we are going to find out in a cluster level optimization. And after a single cell function test, that means testing over a single cell, you are testing cluster 1 first, then moving to cluster 2, moving to cluster 3. So that means now you have covered each and every cluster. Sometimes we have a problem in handover, like that will call as ping pong handover problems. Ping pong handovers are basically a handover related problem, and this area is called as ping pong zone. Now, ping pong zone or ping pong area is two cells. If this is my cell 1 and this is my cell 2, it is asking handover to this cell because RSRP value of this is more. So UE will demand handover to this cell. Then it's become more, so handover again to first, handover to 1, second to 1. That means you have continuous handover between two cells because your RSRP values are fluctuating, and your user equipment will confuse where attach. That means why your RSRP is fluctuating, because UE is not able to find out the appropriate cell attach on. So you will have a problem here, and that type of handovers are ping pong handovers. And this zone is ping pong zone, and we require to find out all the zones, and then we require to optimize that why there is handover related issues and why there is ping pong handovers in this particular area. So that means we have got cluster 1, cluster 2, cluster 3. We have recorded all the parameters. Now let's move to the next one, that is market level optimization. So market level optimization is the big one. That means it is a combination of whole clusters. Now you have to cover the full market. We require to cover out the whole market, so that your market means whole area which is allocated to you, or you have provided coverage to the whole area. That means we require to monitor, we require to check out all handovers in a market, whether my network is working properly or not. In short, I can say that optimization has majorly with network performance, because if my network performance is good, then only I have more number of users, more speed, and that's why more quality quality of service and more number of users. That means that's why we have a continuous optimization of the network to find out the various irregularities in the network. Other than these, we have various issues that optimizers that are sometimes we require to have coverage improvement. My coverage is not good and we require to improve the coverage. So this is also a function of optimizer that it has to improve the coverage of a particular area. We have to interference control. We are receiving more interference. We require to control all the interference. So again, function of optimizer. Optimizer is required to check out all e-NodeB parameters. e-NodeB is not able to last the difference that's providing handover whether neighbors are properly configured or not. We require to check out the configuration basis, neighbor basis. All radio access network parameters, all power parameters. What is the signal to assign our values there in e-NodeBs? How much power e-NodeB is radiating? What are the UE categories and configurations? UE stands for equipments. So that means optimization will cover all the network performance issues and how to improve the network quality. The main aim, that means for optimization, our main aim is to improve network quality and thus having good network performance. So this is about LTE optimization. Thank you so much.